Hi again, it's Mr. Maloney. This is how to answer questions in exams with a focus on calculations, trends and patterns. Here we go. So to calculate, it's using numbers given in the question to work out the answer. You will have a calculator in every one of your science exams. So make sure that you're familiar with using the scientific calculators to increase your confidence when it comes to these questions. Think, what equation do I need to use? Is there a conversion involved in that question? It might help you to underline or circle the numbers that are given in the question to then guide you through each step if it's a multi-step calculation. Calculations and math skills are two major part of your science exams. They are going to make up a total of 10% of your biology grade, around 20% of your chemistry, and around 30% of your physics. So if you're a combined student, then that makes up a huge proportion of your total marks, and as well for your triple, it tells you there. This method is known as FIFA. It's a good way of remembering what steps that you need to take when performing each calculation. The first step is F, so F for formula. So this is where you write down the equation that you're going to need to use in that question. It's a really good idea to write down that formula in the space provided. You might need to consult the equation sheet. I would always check the equation sheet to see what equations are on there. The equation that you need may be on there, it may not be on there, depending on the question. I stands for insert the values. So first identify the key information from the question, then insert the values into the equation. So you put your numbers into that formula. F is for fine tune, so you check the values you've inserted to see if they need to be converted between those units. You may need to then rearrange the equation to make what you're looking for the subject of that equation. And finally, A, you write your answer, you check to see if there are significant figures or decimal places, and include the units if they're missing and if you are asked to include the units. So let's have a look at this example. The battery is fully charged when it was put into the mobile phone. The battery discharged when the mobile phone was switched on. The average power output of the battery as it discharged was 0.46 watts. The time taken to fully discharge the battery was 2,500 minutes. Calculate the energy transfer by the battery. How are we going to go about doing this? Well, F is the formula. The formula that you're going to need for this question is power equals energy over time. So write your formula on the space provided and then insert your values into that formula. We have the power output highlighted as 0.46 watts. The time taken to fully discharge was 2,500 minutes. So therefore, 0.46 watts equals the energy divided by 2,500 minutes. However, this unit of minutes needs fine tuning. So we move on to our next step. So 2,500 minutes needs to be converted into seconds because that's the standard index unit in science for time. So 2,500 minutes, multiply that by 60 seconds per minute gives you a time of 150,000 seconds. So there's a conversion step in this question. So the values we then insert to the formula would be 0.46 watts equals the energy divided by 150,000. So using your calculator, we could then rearrange this formula. So this is another part of the fine tune. The energy transferred will be the power multiplied by the time. So 0.46 watts multiplied by 150,000 seconds will provide you with the energy transferred in joules. And we have 69,000 joules as our energy. Again, check each step on your calculator because it's really easy to make a mistake. Here's another example. The extension of the spring is 80 millimeters. The spring constant is 40 newtons per meter. Calculate the elastic potential energy. Use the physics equation sheet. So that's where you'll find the correct equation. You need to use it in your calculation. So the first step that we will do is we find the correct equation. So the correct equation for this calculation would be that the energy, the elastic potential energy, is equal to a half, 0.5, times by the spring constant, times by the extension squared. Now, the extension given in the question was 80 millimeters. This value needs to be converted into meters because meters is the standard index unit for your science exams. So to convert 80 millimeters into meters, we'll need to divide that by 1,000, which gives us an extension of 0.08 meters. Note the mark scheme. It allows a correct substitution using an incorrectly or not converted unit of the extension. But now we insert the values into our formula. So highlighting this on the mark scheme in orange, the elastic potential energy is equal to 0.5 multiplied by 40 multiplied by 0.080 squared, and that is bracketed as well. On your calculators then, it results in an answer of the elastic potential energy of 0.128 joules. Again, look at the mark scheme. It allows a correct calculation for an incorrectly or not converted value of extension. So for all 3 marks, all 3 steps will have to be done correctly, and then you can check your answer again. Here's a question for you to have a go at yourself. Again, try and use that FIFA rule. The player accelerates at 25 meters per second squared when a resultant force of 1,800 Newton acts on her. Calculate the mass of the player. Pause the video and you can try and do this yourself. Think what formula links mass, acceleration and force. Hopefully you would have included force is equal to the mass times by acceleration. And then we can start to insert our values. So here's the mark scheme. The force was 1800. The acceleration was 25 meters per second squared. We then need to rearrange that formula to make mass the subject of the equation. So the mass is equal to the force divided by the acceleration. So we've got 1,800 divided by 25, resulting in a mass of 72 kilograms, with kilograms being the standard index unit for mass. And so check your steps. Final example for you to have a go at yourselves. So just have a look through this question, compare it to the mark scheme, 3 marks available, see how you get on. Another example here. So pause the video. It's worth 3 marks. You need to calculate the temperature of the water in the kettle after 2 hours. Read through the question. Try and follow those steps. formula, insert your values, you fine tune it, think about your answer. On to looking at trends and patterns. So it's not a command word as such. This is looking at questions where you have to use data in a graph or table to answer a question. So think, what is the data telling me? What is in the headings on the axis? Do you know all the keywords you might have to use to describe the trend? So look at this practice question. This question is about fuels and energy. Figure 1 shows the percentage of electricity generated in the UK between 2007 and 2017 using oil and solar energy. We have on the y-axis the percentage of electricity generated, and the x-axis we've got the year. We've got a key showing us two different bars showing us the percentage of electricity produced using oil, and a second one producing solar energy. So describe the changes in the percentage of electricity generated in the UK between 2007 and 2017 using oil and solar energy. Use data from the figure. So describing the changes is then we're looking at a trend. A trend is a change, and we can look at what's going on here. For 3 marks, to use data in our answer, we need to use some kind of numbers. So we're looking at the differences. For example, the use of oil has decreased by 0.8%. You can go back in the video, you can look and you can compare the use of oil. You may have said that the use of oil has decreased from 1.3% to 0.5%. So it's gone down by 0.8%. That's the same mark available. The use of solar energy has increased by 3.4%. And the use of solar energy has increased from 0% to 3.4%. 1 mark was available for any of these points. The use of oil has increased from 2007 to 2009 between those years. There was no change in oil between 2013 and 2015. There was no change in solar energy use between 2007 and 2009. The use of solar energy has increased the most between 2013 and 2015. And between 2007 and 2011, more oil was used, and between 2013 and 2017, more solar energy was used. So again, you can just go back on the video and you can look at how the changes in percentage of electricity between 2007 and 2017 of oil and solar energy, and look at using the data, the numbers that is shown on that figure to support your answer. This example, we've got figure 4, we've got a force in newtons on the y-axis, the extension in meters on the x-axis. The student concluded the extension of the spring is directly proportional to the force applied to the string. Describe how figure 4 supports the student's conclusion. So it's this key term of directly proportional. It requires an understanding of what that means. The line is straight and it passes through the origin. So the origin is the point on the graph where both axes meet, and the line is straight. The line does not curve and it follows a constant gradient. So any of those points would give you 2 marks. If we said the line was straight and it passes through the origin, most pupils would have missed this point, that it passes through the origin, for it to be directly proportional. Another example, final one. Describe the effect of temperature on the time taken for goat's milk to reach pH 5. Use data from figure 1 in your answer. So again, we're using data. We're looking at the temperature on the time taken for goat's milk. So I'll highlight goat's milk here. Note the key of this line representing goat's milk, which is the dashed line, but it's not the smaller dashes. It's the dashed line with the medium-sized dashes. So we've got this trend here. We need to describe the effect of the increasing temperature on the time taken to reach pH 5 in days. And we need to be using these terms in our answer. How does the temperature affect the time taken to reach pH 5? So let's have a look. As temperature increases up to 15 degrees, the time taken to reach pH 5 decreases. Keywords when describing trends and patterns: if it goes up, we'll say it increases. If it goes down, we say it decreases. Allow the converse, so if you put it the other way around, that's fine. If the temperature decreases, then the time taken to reach pH 5 increases. Above 15 degrees Celsius, the time taken to reach pH 5 stays the same. Final point on this mark scheme: if no other mark was awarded, allow 1 mark for as the temperature increases, the time taken decreases and then stays the same. Okay, see how this answer hasn't included any data, therefore doesn't warrant the second mark. So if you've correctly described the trend, but without using data, you would lose a mark on this question. So you'd need to use some form of data, and at 15 degrees Celsius is where there is the change in that pattern. Okay, so I hope this helps. Thanks for listening.